Hello, everyone. Thank you for having me. My name is Miriam Nyamai, and I'm from Kenya. I'm going to talk to you about my journey as a NASSP, from NASSP to MeerKAT. My background is I did a Bachelor of Education Science, specialized in mathematics and physics. So I'm a trained, I was trained to teach high school. But then after I finished my degree, I decided to quit, basically. I was employed by the government, but when I heard about NASSP, I decided to change and try NASSP as a program. I did NASSP at honors and master's level. My Bachelor of Education degree was 4 years. So when I came to NASSP, I did an extra year, and that was the longest year of my life. But eventually, I managed and proceeded to master's. I did my master's coursework at UCT and went to University of the Free State to do my research. Later, I applied for Women in Science scholarship and South African Radio Astronomy scholarship to do a PhD. And I got both scholarships, but then I decided I had to choose one. I was supposed to take one at University of Free State, and the other one I could only take it at UCT. So I came back and worked with Patrick, Professor Patrick at the department. Since then, I worked as a postdoctoral fellow at UCT for a year, and later I joined Soreo as an associate operations scientist. I enjoy writing, not necessarily science. I also write other things, especially books. My background with NASSP is that I heard about NASSP through one of the professors. I'm not going to tell you the name, but thank you, wherever you are. And when I came, I had problems with my visa when I applied back in Kenya. So I only came a week later when the other students had started summer school. And when I came, they were very friendly. I only remember 4 ladies that came to, no, I remember Nikki, and then later 4 ladies that came to pick me up and at the residence and took me to SAO. At that point, I thought, okay, this looks friendly, so this should be fine. Then I also liked the trips to Sutherland and Carnarvon. At that time, I saw SALT telescope, which was very huge. And later, we also went to see CAT 7. What I can say about NASSP is that the NASSP planted the seed for me to start a career in astronomy. And the financial aid was very helpful. I also made very good friends. I've met people who we're still friends up to today. And ultimately, through NASSP, the program introduced us to astronomers and professors and researchers in the field, and we were able to start from there and make collaborations to international levels. I've attended 2 schools during my NASSP time, also PhD, and that NASSP was really the seed that John was talking about. So this picture is taken after our NASSP honors exams. We were very happy that you could see the smiles that eventually we made it. And I remember after that, then everybody just went separate ways. But we're still friends up to today, so I'm grateful for that opportunity. Right, so after NASSP honors and masters, as I said, I carried on to do a PhD, but this time around under different funding. What I did for PhD was purely radio. I committed my life to just doing radio because I admire radio astronomy. And I remember when I was doing, when I started my PhD, I basically use radio telescopes. There's a lot of archival data out there, so I used archival data to make pretty pictures. This is what I'm showing you right here. I'm not going to details. I also make very nice light curves where I measure the brightness at radio wavelengths and the time of a system. It could be anything, not anything, it could probably be, mostly I'm interested in transients. So after I make those pretty pictures that I've just shown you here, then I'll use some packages, and then I'll measure the flux, and it varies with time. And these two light curves are showing different objects. I'll go into details later. After I finished my PhD, I briefly did postdoc, and later on I went to join SAREO as Associate Operations Scientist. I think most of us know what MeerKAT does, but I'll briefly say that it's located in Caravan. It operates with, it consists of 64 interlinked dishes, and it's been doing science since 2018. My work as an operation and commissioning scientist consists of 3 parts. One is I'm usually the astronomer on duty on roster basis. That means that when I am on duty, I'll facilitate the operations of the telescope. So if you've submitted an observation to be observed by MeerKAT, and then I'm on duty that week, then I'll communicate with you to say whether your observation has been observed, and it has been observed and completed. I'll also make sure that it is done correctly. If there are any issues, then I'll assist with troubleshooting that. The other thing that I assist with is open time proposals. When you submit your open time proposals for MeerKAT, then I'll help with looking at the support tools that you use to calculate, for example, the sensitivity that you need. And I will also look at some of the proposals. I look at the technical justification. For example, if you say you need 20 hours on target, does that give you enough sensitivity to do science? Then the last bit that I do is I do commissioning, MeerKAT commissioning. I've been tasked with establishing a MeerKAT S-band calibrator database. As you know that MeerKAT operates in 3 bands, L-band, UHF, and S-band. So my task is to establish a database for phase calibrators for S-band observing frequency. When you're observing with radio telescope, you have to make sure that you observe a phase calibrator that is close to your target so that you can mitigate atmospheric effects. And then lastly is I do research. My research is radio transients. I focus on nova eruptions. That was extension of my PhD thesis. I've recently introduced X-ray binaries and radio transients. I'll briefly talk about them. Nova eruptions occur in a binary system where you have a white dwarf, which is right at the center there. It accretes mass from the companion star. And then once enough material is accumulated on the surface of the white dwarf, then it goes through what we call a thermonuclear eruption. During this time, the outer layers of the star are ejected. And what I'm interested in using the radio observations to trace that that ejected material. The reason why this is important is because they are thought, novae are thought to be supernova type 1a progenitors, but for them to go to supernova stage, the white dwarf has to accumulate enough mass. So we use radio observations to see if the mass accreted on the white dwarf is more than the mass that is ejected from the white dwarf. The other subject that I focus on is X-ray binaries. This is very new to me. I just started recently. But in X-ray binaries, you have a neutron star, that dot there. Then it accretes mass from a companion star, and in the process, there's accretion processes and there's ejection of jets. So I'm interested in the X-ray and radio correlation between the two. And I am currently reducing data for one of the interesting objects, MeerKAT data for one of the interesting objects that we are studying. And then finally, I like looking at radio transients. This plot shows luminosity versus frequency and the time it takes for a transient to stay bright, basically. So it's a radio transient plot. It shows different transients. You can see pulses, fast radio bursts. I would also like to look at fast radio bursts at some stage. And on the left, there's novae, X-ray binaries, and flare stars down at the middle. I mean at the bottom. So what we did is we leveraged, as you know, MeerKAT has been observing, has been taking data for the large survey projects, the Mongoose, Phonex, Thundercat, and all that. So they've collected, MeerKAT has collected a lot of data over the years since its operation in 2018. And we leveraged the fact that it has a very wide field of view, and some LSPs like Thundercat observe fields for a very long time, say once a week for a year. Well, we leveraged that and we went blindly and searched for any interesting transient in one of the MeerKAT fields. And this is one of the many images that we looked at. The target was a nova system, P603 AQL. It was observed with MeerKAT for quite long. So we searched each image and we found a flaring star. I won't go into details. That is what I do for in the science part or research. However, I'm also involved in outreach. I've participated in development in Africa with radio astronomy. In 2021, I tutored those students at Namibia University of Science and Technology for 2 weeks, where we teach them radio techniques and radio data reduction. I must say that this is not only me who participate. We are a group of us, and they have lectures and they have tutorials that you use for that. So if you want to participate, you don't have to do all this, the lecturing on your own. So there's materials that are ready for you to use, and there are lectures that are online, and it's a combination. So I was in Namibia, but we could talk to students that were in Kenya or Madagascar or Botswana and all that. The next workshop that I'm going to participate in is at University of Pretoria with Jack Radcliffe, and will be held in March 2024. I must say, before I move on from this slide, I think the one thing I wanted to mention is that we have attempted to encourage young students to join sciences, and we're now moving to inclusivity and equity and all that. But I think we still need to encourage more students to come on board and do science. So my last slide, my research output so far, I've been able to co-supervise a honor student. That was, I think, in 2021. I've tutored data students on radio astronomy techniques and data reduction procedures. I've submitted MeerKAT open time proposals. 2, I've been a PI, I was the PI, principal investigator, and the one I was a co-PI, and all of them have been successful. 1, or the 2, we've already published 2 papers from that, and 1, we are busy working on it. And through research, I've been able to establish collaborations, especially with people who are working on radio telescopes around the world. I work with people who work with eMarlin, VLA, and LOFA. Of course, scientific publications is inevitable. And lastly is that in future, I would like to do support. I still want to be a support scientist. I want to support radio telescope operations, and I also want to do research. And then lastly is I've also been a mentor to students outside South Africa. Thank you.